We are with the thalamus. So I would have to say the thalamus can be really tricky, but once you know how to draw it and how to approach it, it makes things so much simpler. There's a lot of stuff going into it and a lot of stuff going out to it, and that's kind of the big thing how a lot of board question makers will present it to. So you have to know what is going into each of the respective nuclei and what is going out to. So earlier we talked about the basal ganglia going from your premotor cortex through the basal ganglia to check and make things everything else really smooth with your movements, and then out through the primary motor cortex. The thalamus is the opposite, where you have your afferent nerves, whether it be from your spinothalamic tract or dorsal column medial lemniscus tract, coming up through, and it has to go to the thalamus before making its way back into the post-central gyrus, or your somatosensory cortex of your cerebrum. So basically, kind of like how the basal ganglia is a little bit of a check and balance before you're sending out a motor signal, this is going to be a check and balance to see, okay, how serious of a threat it is, and it will send it up to your somatosensory area of your cortex to further integrate that information coming from your external environment. With all those fancy words aside, I went ahead and just threw this picture that I found up on here. It does a good job of just kind of showing the 3D relationships of where the thalamus is. Oftentimes, especially particularly in my slide, I'll only throw you one thalamus, but this is a good way of showing the relationships of all the different integrations of the thalamus and where you will see the signals going to. Particularly here, I don't get into it in great detail, but the prefrontal cortex, the ventral anterior going to the prefrontal cortex, and then you have your ventral lateral going up to your motor cortex, and your ventral posterior will coming up to your somatic sensory. So that's the purpose of this, just to show you kind of on a three-dimensional figure where the signals are going to on the cerebrum itself. Because as you'll see, my cerebrum drawings are a bit lacking compared to the thalamus drawing. And it's also important to know that your two thalamuses are actually communicating with each other. I know that's something whenever you're just focusing on one thalamus at a time that can seem to get lost. So after looking at my drawings, please refer back to this figure so that we can kind of relate parts of the thalamus and how they're connected to the cerebrum, because I know that's another good way of showing the relationships to what part of the thalamus is affected and what is the signal going from the thalamus up to the cerebrum and what is going from the peripheral nerve system out through the thalamus. So without further ado, let's get into it. Alright, let me just go ahead and open up all of these guys so we have everything. So, with this thing, there's a lot going on. The first thing I want to do is just tackle the basic outline of the thalamus. So, this is everything. You guys know my style. I like just throwing everything at you and just slowly picking it apart, so as opposed to doing it one slide at a time. The big thing whenever it comes to do is just drawing it out. Just like with the tracts, just like with the basal ganglia, if you can draw out the thalamus, there's not a single question that test makers can throw at you that you won't be able to answer once you have the drawing just spewed out on your scratch sheet. So the drawing here is just pretend that you're drawing a fish, right? You have your basic circle with two little back fins here. And then you just want to draw a simple line across to make your dorsal medial nuclei. Then once you have that, then you just draw four lines. One to make your anterior here at this angle, one to make your pulvinar nuclei in the back, and then just two more smack dab in the middle. So that's just kind of your basic outline. So once again, you just draw your big circle with your two little flippers on the back. You'd have this kind of line here, just kind of dividing it into a third. Then you divide that to a back section and a front section, and then you just draw two more lines. So now that you've done that on your scratch sheet of paper, go ahead and we can start filling out the stuff. I'll go ahead and do the lower yield nuclei, I feel, just so that we can get that stuff out of the way so we can get into more detail on the stuff that I think is going to be more likely to show up on your board exam. And that is, we'll go ahead and start with the dorsomedial. Just know that its main function is in the integration of emotional expression, and because it's on the medial aspect, it will have a strong connection with the other thalamus, so they're able to communicate back and forth through the dorsomedial. Another thing I want to note is this line dividing up the thalamus. You could almost say it's kind of like a weird janky Y, is the intralaminar nuclei, which I have written out down here. Its function is in the processing of pain. So if you ever have any sort of like stabbing pain, this thing kind of helps to modulate that. Another thing to note is the pulvinar nuclei, which is out here in the back. Its job is the integration of sensory information, which makes sense because just like with the cerebrum, just like with the spinal cord, most of your sensory stuff is going to be in the back, your motor stuff is going to be in the front. So motor in the front, sensory in the back, just like with spinal cord, just like with the cerebrum. So that's what I would have to note about the pulvinar, is just know it's the integration of sensory information. And then the last kind of like I would say structure to just kind of note is the reticular nuclei. It is the bodyguard of the thalamus. If this thing is taken out, then you will just have an overstimulation of the thalamus, and you will have so much sensory stuff, you will develop what's called thalamic pain syndrome. I have a slide devoted specifically to that, but this basically kind of slows down the signal coming from the thalamus to the cortex. So instead of like throwing a signal like 1,000 miles an hour, it's now just at a steady, like handleable, like 100 miles per hour or something to that measure. So that's the significance of the reticular nuclei. It's just like this barrier that just slows down these signals so you just don't have sensory overload. So those are the things I just wanted to get out of the way, and so now we can kind of get into these nuclei along with the geniculate bodies in the back side of the thalamus. So starting from the front is the anterior nucleus of the thalamus. This guy is particularly part of the limbic system. Just to be familiar with the arc of the limbic system, going from the anterior nuclei of the thalamus to the cingulate gyrus, back to the hippocampus, through the mammillary body, and back to the anterior part of the thalamus. So that's the only thing I would have to say about the anterior nucleus, is just know that it participates in the limbic system. And is part of your emotional controls. So now that we move from the anterior, this is going to be VA, which stands for ventro-anterior. Ventral anterior. And these will get confusing, I promise, but it'll make sense if you just slowly approach it from front to back. It is the ventral anterior nuclei of the thalamus. So it's going to be on this lateral aspect of the thalamus, and it will primarily receive signals from the basal ganglion. It does receive a little bit from the cerebellum, which makes sense because the basal ganglion, which is part of integrating and making motor signals out through the body, it would make sense that a signal from the basal ganglia would come through here that's going to go to your motor nuclei. So, like I said, since this is coming from a primarily motor controlling system, the basal ganglion, it's going to go to the precentral gyrus, or precentral part of the cerebrum. I wrote a 6 here, noting that it's going to the Brodmann area 6 from the ventral anterior nuclei. So, as we slowly work our way down here, we have the ventrolateral nuclei of the thalamus. So going from ventro-anterior to the ventrolateral, we are completely on its side. And this guy will receive signals primarily from the cerebellum, because whenever you're carrying out a motor signal, you need to know if you're where you're at in a three-dimensional space, and is the signal being carried out in a correct way. So the ventral anterior handles the basal ganglion portion of it, and the cerebellum is going to be primarily sending signals to the ventrolateral thalamus. And just like with the basal ganglion, it's going to the precentral area of the brain, particularly Brodmann area number 6. So it's all part of like making a smooth motor function, so it makes sense that both the basal ganglion and the cerebellum have a common area that they're sending their signal to from the thalamus to the precentral gyrus of the brain, or Brodmann area 6. So, now that we've covered our motor, because like I said, the common theme in neurology, motor in the front, sensory in the back, we want to go through the different areas of the back side of the thalamus. You have the ventro-posterior lateral and ventro-posterior medial. lateral because it's on the lateral side of the thalamus, medial because it's on the medial side of the thalamus. It's posterior because, like I said, we're on the back side of the thalamus. That makes sense. And it's ventral because all these other guys are going to be on the ventral side of the thalamus. So that's a common theme, is that you got ventral everywhere, you have an anterior, a posterior, and a lateral smack dab in the middle of it. So the ventro, posterior, lateral. Do you remember whenever we drew out our tracts in the tracts lesson that I put out to you guys, that you have your spinothalamic tract and your dorsal column medial lemniscus tract? The spinothalamic detecting pain and temperature, your dorsal column detecting proprioception, fine touch, and what's the word I'm looking for? Proprioception, fine touch. Let me look that up. Proprioception, fine touch, and it eludes me right now. But knowing that it does pain and temperature for spinothalamic, dorsal columns do proprioception and fine touch for those guys will go to the ventral posterior lateral nucleus of the thalamus. Before in the tracts lesson, I only showed that is going to the thalamus, but now we're going to go into the specific detail that it's going to the ventral posterior lateral. It makes sense because your limbs, which are primarily being detected by the spinothalamic and dorsal columns, are lateral to your face, respectively. So it's going to the lateral ventral posterior nuclei of the thalamus. So spinothalamic and dorsal columns are going to the lateral part of the thalamus in the ventral posterior aspect of it. And where does the signal need to go to? Just like with the tracts lesson, it's going to the somatosensory portion of the brain, the posterior central gyrus. And same thing here, since we're in the posterior aspect of the thalamus, our sensory is going to the back of it. We're on the ventral aspect of it because that's just where the rest of these nuclei are resting. We are going to the ventral posterior medial nucleus. It receives signal from our ventral tegmental tract, which is all of the sensory from the face. And since, like I said, the face is going to be medial compared to our limbs are going to be lateral, face being medial, the ventral tegmental tract is going to the VPM, the ventral posterior medial nuclei, and that also is going to your posterior central gyrus, or post-central gyrus. This line here being your central sulcus. Now, just imagine your homunculus man where his feet are dangling at the top and his face is going to be on the far lateral side of it. That would kind of give you a better idea. That's why these arrows from the medial aspect are dangling here versus the lateral arrow is all the way up here to the top. So now we are slowly working our way back. We've already discussed pulvinar, and let's do these little danglies at the back of the thalamus. We have our lateral geniculate body and our medial geniculate body. I don't have a picture of them, but like I said, they are just kind of like hanging off at the end of the thalamus. The lateral geniculate body, I always think of, well, I'll direct your attention here to the top left, is lateral handles laser eyes, or is handling your eyes. And anytime I think of lateral geniculate, think of laser eyes, kind of like this dude up here. It receives signaling from your superior colliculus, versus your inferior colliculus is handling music or any sort of sounds. The way I remember it is your eyes are above your ears, so it makes sense that the superior colliculus is going to be involved with vision, your inferior colliculus is going to be involved with sound. So you're going to have your vision signal coming from the superior colliculus to the lateral geniculate body through the retrolentiform radiation, and it will send its signal to the occiput, because we all know that the occiput part of the brain handles vision specifically. So once again, it's going from the superior colliculus, because your eyes are above your ears, to the lateral geniculate body, from the lateral geniculate body through the retrolentiform radiation or pathway to the occipital lobe. Now, the inferior colliculus, because your ears are below your eyes, is going to the medial geniculate body, because medial geniculate means music, and we listen to music with our ears. From the inferior colliculus to the medial geniculate body to the temporal lobe. It will go to the ipsilateral lobe. And same thing here. The lateral geniculate body will go to the ipsilateral occipital lobe. And I went ahead, just as kind of like a review, is that your lateral geniculate body equals laser eyes, ipsilateral, and your vision is handled by Brodmann area 17. 17-year-olds are so vain, and so is this guy. So just think of laser eyes, Brodmann 17, lateral geniculate body. And that will handle any vision stuff around your thalamus. And like I said, medial geniculate body, you listen to music, so music, medial geniculate, MM, and 41, 42, so I can hear you. That's your Brodmann area for any sort of music or in your medial geniculate body. Once again, going to the temporal lobe of the brain. And this is just kind of a reminder of what your basal ganglia are. Once again, just shout out to the other video that we have recorded out here, knowing that the striatum is made up of your caudate and putamen, and the lentiform / lenticular nucleus is made up of your putamen globus pallidus, and that's why these things are called the sublentiform and the retrolentiform. The sublentiform is going directly underneath the lentiform or lenticular nucleus, so it's going underneath the putamen and globus pallidus, versus the retrolentiform is going backwards or behind. So this is going underneath the lentiform nucleus, this one is going behind. So that's why they have those names, and that's why I included it on the slide, just to kind of help explain, and you're not just having to memorize words for nothing. And I just put these slides just as a reminder of the tracts. Remember particularly that the thalamus is receiving signals from the secondary neuron of both the spinothalamic and the dorsal column tract. And then the thalamus will be sending its tertiary neuron up to the cerebrum, more specifically to the postcentral gyrus. Yeah, okay, here we go. So we got, let's see, what was the other thing? So it does 2-point vibration, that's what it was. For dorsal columns, it's 2-point discrimination, vibration, and proprioception, aka fine touch for 2-point discrimination. And just a reminder from the tracts video that we had recorded before, in spinothalamic, we got your P and your T for pain and temperature. Once again, it's going from the thalamus via the secondary neuron, because you have your primary, secondary, and then it will synapse in the thalamus at the ventroposterior lateral, because your legs and arms are lateral to your face. And then your tertiary neuron will be going up to the cerebrum, more specifically the postcentral gyrus. And this is just kind of me redrawing up the thalamus, but just a way to explain thalamic pain syndrome. I know this can happen where you have a lesion, because you know that neurology loves its lesions and different kind of stroke symptoms. Knowing that a lesion to the thalamogeniculate artery, which is a branch off the posterior cerebral artery, can cause extreme contralateral pain. At first it's numbing, but as time will pass by, like they can't look at a light without being in the worst headache of their life. They would just be in miserable pain, and that's because you have a lesion or some sort of infarct to the thalamogeniculate artery, and that takes out your reticular nucleus here. So all those signals are just going nuts, and it's just going making a direct shot to and you're taking out your ventro-posterior medial and lateral signals, so they are just going crazy and sending all kinds of signals, so that therefore the pain signals are just overwhelming to your brain. You have no way of like moderating it. So with that, I bid you guys adieu. Good luck on your exam. Keep studying. Once again, just like with the basal ganglia, just like with the tracts, memorize this drawing, break it down into simple like fish drawing where you have your two little fins in the back. This division here for your dorsal medial. Once again, you have your Y up top for your anterior, and then you have all of your ventrals, your ventral anterior, your ventral lateral on the far end. You have your posterior medial, your posterior lateral, and finally your pulvinar. Once again, good luck, guys, and I hope this helps.